So once we have the serial.begin put into our setup function, now we need to use it in our loop function. So I'll say serial.println. So print ln, that is an L, a lowercase l. And case matters, whether things are capital or lowercase are important here. So make sure that you are following along to the letter. And so in here, I'm just going to say hello in quotes. And once again, end that with my semicolon. And now, if I have my Arduino plugged into my computer, I have the USB plugged in. If I go to Tools in the Arduino file menus, or sorry, the Arduino app menus, and I scroll, or not scroll, I just go down to the port item in the menu, I should see one of these that says Arduino. And so just, we don't need to memorize what's happening here, but just take note of where we can find the name of this port. If you're on a Mac, it'll look something like this. If you're on Windows, it may say COM1 or COM3 or COM11 or something like that. So just look for the one that says Arduino next to it and make sure that that is selected. And when we look back, we can see that it is selected in the menu. And so if all of that has worked out successfully, then I can click this arrow here that is the upload button, and I'll click it. And this is a good time for you to save your sketch. I'm not going to save mine just because I have enough Arduino sketches saved as it is. So I'll just press cancel, and now it'll upload that to my Arduino board. And so now, if I open up my serial monitor right here, I can see this running through, hello, 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 hello. And this is something you can also do in the Tinkercad circuits. If you're following along in there for now, you can go to code, remember? And if you go to the text option in this drop-down menu, then you can do all of that in here. And the serial monitor, there's a virtual serial monitor. So yeah, so this is a super basic, not very useful use of the serial monitor, where we're just printing some text from our Arduino into Arduino's serial monitor. But what we can do is we can use this to send data from the Arduino to our computer to control any number of things. We'll be controlling a P5 sketch, and we'll also be using P5 in our browser to control the Arduino. We're not going to do anything super crazy, like no motors are going to be whipping around today, but that is something that we can do if we want to do so further down the line. I just wanted to point out a couple things on the board here. So this this light right here, this green light, where it says TX and RX are terms that are used for this communication via our serial connection. TX, the T in TX stands for transmit, and the R in RX stands for receive. And so right now, this light is blinking very, very quickly. We can't really see it through the camera, but it's blinking every time we send data through the wire to the computer. And if I had just loaded up the blank Arduino sketch, we wouldn't see this light on. When I do the actual act of loading the sketch, I'll just press load the sketch, and we'll see both of those lights blink. Because during the process of loading the sketch via our USB connection, data is coming across. That's why our RX was flashing, and then the TX will flash basically like confirmation that the sketch is successfully loaded. Just I want to point out right over here, we can see on pins 0 and 1, we also have an RX and a TX marked. And this is telling us that these two pins are electrically connected to what's happening in our USB cable. And that's why if you're doing a project with Arduino, we want to just, in general, stay away from these pins for common use. Like we don't want to attach buttons or other components to these pins because that will disrupt the ability of the Arduino to communicate over its serial connection. So just general rule is avoid pins 0 and 1. We're already communicating over our serial port, but now let's get going with something a little bit more fun. The next step is going to be wiring this situation up. So just going over what we have wired here, we have that button. And remember, because of the internal conductors inside of the button, this leg and this leg are always connected to one another. So that means that this wire that goes to pin 2 on the Arduino is connected not only to this button, but it's also connected to ground through this 10,000 ohm resistor. And this resistor is called a pull down resistor because it's allowing any buildup of electricity to discharge down to our ground, where we have this connected. Let me zoom out. Have another wire going from our ground rail, where all of these pins are connected. And then they're connected through this wire to the ground pin on the Arduino. You can use this one, this ground pin, or this ground pin, it doesn't matter. And then we have this other wire, which is connected in our breadboard to all of these pins. That's going through this wire to our 5-volt pin on the Arduino. So following our 5-volt connection, we have our wire going into the breadboard here, and it goes to both of these red wires, which then in turn are connected through the breadboard to the other side of our button and to one side of our photoresistor. And we'll see that our photoresistor also has on its other leg a 10K resistor connecting that side to ground. And that side of the connection is also wired through this wire here to pin A0. And so it's not going to be as clean as this virtual version looks. It's going to be a little bit more bird's nesty. So my setup looks like this. Just be very careful that your power and ground are not connected to one another directly, because that will overload the board. It'll be a short circuit for the board, and it won't have enough power left over to do any of its computations. Now, if we have this properly set up and we are still receiving a hello through the serial connection, that means that nothing is wired in a way that's going to short out our Arduino. And that's all good. So now it's time to get some more useful code in there. So once we have that code copied into our Arduino IDE, let's look at what's happening in here. So the first thing that I want to point out here are our global variables that we're going to be using. And remember, in Arduino, the data type is, we have to be specific. We have to include information on what kind of data each variable is going to hold. So we have two integers. We have our analog value, which is going to be the information that's coming from our photoresistor, because that photoresistor is going to tell us how much light is falling on it. We have our digital val, because remember, digital is yes or no, it's binary. That's going to be our information that we're getting from the button. So when I press the button, it's going to give us a 0 or a 1. 0 meaning not pushed, 1 meaning yes pushed. And then we have a string, which is like a text type variable. And it's specifically, we're calling it a delimiter. And we're calling it a delimiter because it's going to, that's a term that means like something that divides two pieces of data. So we're going to be taking the information from our photoresistor and our button and smushing them together, but in between, we're going to put this delimiter. So when we send that data across the wire, as just a series of zeros and ones, the P5 sketch will be able to look for that ampersand symbol once it decodes that those zeros and ones. It'll be able to say, okay, I need to, this is two pieces of information split on that ampersand. So that is the purpose of this variable here. We also need to have a variable that's going to hold data that's coming from our computer and going to the Arduino, and that's going to be the incoming data. Continuing on through our code, we have our setup function, and in this setup function, we have to declare our pin modes, which is going to let the Arduino know whether it should be listening for information or it's going to be speaking, whether it's going to be outputting data. So on pins A0, which is one of our analog input pins, and pin 2, one of our digital input pins, we're going to be receiving information from our photoresistor and button, respectively. Pin 13 is going to be our output, and pin 13 is connected to this, this LED right here. There's a built-in LED, right, that pin 13 is connected to. So we're going to be using that pin to show when we're receiving data from our P5 sketch on our Arduino. And we're going to set our baud rate for our serial connection, just like in that earlier, simpler sketch. And now we are into the actual meat of the program, into our loop function. The first things that we're going to do is we need to get some data. We need to read our data from those sensors, from the button and the potentiometer. So we're going to analog read from pin A0, because remember, analog is how much, our photoresistor, I may have said potentiometer. So I have this photoresistor that is going to tell me how much light is falling on it. So that is going to be my analog value. And we're going to use digital read to get the information from that button pin, pin 2. And we're going to store those in our variables that we made up top. This next line of code is going to what's called concatenate this data. And concatenation is kind of, it's not adding, it's where we're putting something onto the end of something else. So it uses the same symbol as addition in this language. In some languages, it uses a period. But in this language, we use a plus sign. And so that's going to give us the number that we get from our potentiometer, which our analog read has a range of 0 through 1023. Our delimiter is an ampersand, and our digital value is going to be either a 0 or a 1. And so it's going to be one number, ampersand, another number. But yeah, just important, when you use a plus sign with different data types, it will concatenate them and not add them. And since we're doing it between integer, string, integer, that's what happens. Next thing we need to do is we need to, well, we've already, this line, this serial.print line, this is sending that information. So we're done sending information from the Arduino. Now we need to work on receiving information from P5 into the Arduino. And the first thing we want to do is we want to check to see if there is a valid connection, right? Because this Arduino can work if it's just plugged up to a battery. It doesn't need a serial connection for the Arduino to power up and run its code. So just to make sure it doesn't crash, make sure it doesn't try to get any data that doesn't exist, we need to first check to see if there is a serial connection. So that's using this method, this serial.available method. And if it is valid, then we are going to read data that's coming in onto that RX pin, essentially, on the Arduino. And we'll save that into our global incoming data variable that we defined up here. Oh my. Finally, in this code, we just need to use a simple condition to turn that LED on or off in case of the incoming message. If that data coming from our P5 sketch is a 0, then we are going to not illuminate our built-in LED. If it's a 1, we're going to supply 5 volts to that LED. And that concludes our Arduino sketch, our simple Arduino sketch. So what we can do now is we can load this onto our board. And if everything is successful, we'll say done uploading. And now if we go to our serial monitor, we see these rapidly changing numbers. And I'm just gonna show something. So now, these numbers are coming from the Arduino, right? They're not coming from our program window on our computer. They're being generated by our Arduino. And so now if I press this button, that this 0 is going to turn into a 1. Press, press, press. Not very exciting yet, but soon. And my photoresistor on the other side, if I cover it, that other number, that first number before the ampersand is going to get smaller. And larger if I let more light fall on it. And so here we're sending 2 separate pieces of information in one message. I want to point out that it's that the way that this communication protocol is organized, the way that I've written it, or the way that I'm using it, the print line, that ln is important because that is putting a new line character after each one of these messages. Let's just for our own edification, let's remove that ln and load up the code. And now if I look at the serial monitor, see it's just printing off into the distance. And the reason it's important that we want to use that print line method is if we don't, we could have a mistake of where one message ends and one message begins. So let's make sure to put that print line back, that ln back, load our code back up how we want it to be. And now we're back to our proper situation. All right, so once we have the P5 serial control app downloaded and we open it up, we'll see the name of the port that our Arduino is connected to. Oh, right, we see 142.301, and if we go back to P5 serial control, we see 142.301. And that's good. Everything is working fine. We can go to this drop-down menu here, select that port, once I have that selected and I click open, then I can, just to check, I can enable my console and then read it in ASCII. And so now I see those numbers that we saw in our serial monitor. And if I cover my photoresistor, that first number changes. And if I press my button, I can see that data coming across in our console in the serial control application. So now what I want to do is I'm just going to turn those off and I'm going to minimize this. I'm not going to close it. I need to continue running this application in the background for the next step to work. So minimize that. And now here is an example sketch that I've put together. And first thing to note, if you want to copy this sketch, do not just copy this code, because this serial connection relies on a library. It relies on this serial port P5 library. So we need this to come along. So if you want to copy this to work from, go to File, Duplicate. So, okay, going back to the sketch.js file. Let's just look at what it does. So I'll run my code. And I've already set this up. So there's one step that you are going to need to take before yours works, which is we need to update the port name variable, the value of the port name variable. And we can go back to our serial control app, connect this here, or grab this text from here. I can just select it and copy it, go here and paste it in, and make sure to leave the quotes there because it is a string variable. But with that done, now if I press my button, we'll engage party mode. And if I cover my photoresistor, I'll just switch my camera around so you can see my hand. If I cover my photoresistor, it's going to change the size of my circle. And so I can, this is not the most exciting use of this data, but I could use like the sound library. I could make this control music. I could have this control the volume of music. I could have it change what's being drawn on the screen in other ways, change the vertices of a more complex shape. Anything that you can do with a variable, you can use these physical computing components for. So all of this first section is mostly about using the data that's coming from the Arduino, but I also wanted to point out this last little bit of the code. So we have our mouse pressed function and our mouse released function in P5. And with that, we're going to be sending data across to the Arduino, right? So we're going to be illuminating that built-in LED. And so now, if I click my Arduino sketch, if I click my P5 sketch, so click, unclick, click, unclick. Now you can see that on my board, I am illuminating that light, and I'm doing that by clicking and releasing the mouse on my computer. So we're just sending one piece of data back across the wire to the Arduino, but we're not limited to that. It's a little bit more complex, but we could have it where there's a couple motors and I'm using my gamepad or something to control a little car that can drive around. Or I could be, I could build a control panel in P5 that runs a few motors that can water my plants or something. But the important thing to realize is that we can control the physical from our computer, and we can control our computer from our physical setup. All right, so yes, really quickly, I'm going to try to get through explaining this code. Please do read through it. There is a bunch of comments in here that go through explaining what's happening here as well. And just oh yeah, one note that I was having a little issue with this functioning properly in Safari. Some other students told me. I don't really ever use Safari, so I wasn't aware of that issue. It works in Chrome, I know. I haven't tried it in Firefox recently. So if you're having trouble, try it in Chrome. Yeah, I'm not sure what the deal with Safari browser, what the Safari browser for this is. But yes. So, okay, going through this code, first thing we need to do is we need to make an object that is going to be connected, that it will be our serial port object that'll have all of the methods that come along with it that are built into the P5 serial port library that allow us to interact with our device here. Next, we have this string that we're passing in our name of our port so that our P5 sketch can find our Arduino. And here we have an array that has 2 elements in it. And that's going to store the data from our photoresistor and our button in those 2 separate elements of our array. And this is going to be related to that ampersand that we talked about before. So continuing on, regular role, create canvas to make our canvas. And in our setup function, we are using the p5.serialport method here that's part of our serial port library to make an instance of that serial port object. Here is a serial.list. It's a method that's going to list out our serial ports. And we will open the connection to the port that our Arduino is connected to. And here are a few event listeners, meaning that when, from this connection, when a message is sent that, yes, we've connected, then it's going to trigger these functions right here. It's going to trigger the running of the got_list and got_data functions, which are defined right here. So inside of our got_list function, all that we're going to do is we're going to write to the console the ports that are connected. So we look here in our console, we can see that there are, on my computer, I have 3 ports open on to various devices, like my Bluetooth earpiece here. But this is the one that we're interested in. This is the one we're interested in, the one that's connected to our Arduino. And so this function, if you're trying to streamline your code, you could delete this. It's not doing anything that makes this function. It just is giving us information that's human readable. And now the got_data function, which is triggered right here when we have an active serial connection. We have a local, we have a variable, a string variable that's going to be reading the data that's coming from the serial connection. And we're using a trim function, and the trim function is going to remove any white space characters like a space, a tab, a new line character. And because we're using that new line character, we are, there's a chance that when it gets received that there's an extra little new line character on the end of that. So we're just making sure that that gets removed. And this line 46, this is a bit of safeguard code here where we say if there is not data in that string, then let's get out of here. And that is going to prevent our code from requesting data that doesn't exist and then crashing when it says, hey, there's no such thing as this data that you're trying to use. And then we are just logging our data to our console, which we can also, that can be removed if you're trying to streamline your code and speed up your code. Also, the console log takes a little bit of time. So if you're trying to speed things up, we can just comment that right out. And now this is part of where the magic happens. We're taking that string that we're getting, which is just this string of characters that we can see in the console. And now we need to split it apart into our two values. We need our photoresistor value and our button value. So what the split function does is it takes an input string and looks for that delimiter that we've defined as an ampersand here. It says, okay, so I have this string that's like 689 and 0. I'm going to look for an ampersand. I'm going to get rid of that, and anything on either side is going to become two elements of an array, specifically our in-message array that we have defined and initialized up here on line 10. And that is the end of our got data function that's being triggered every time new data arrives. Excuse me. And now there's just a little bit left right here where we're drawing our white background. We're setting our fill. And then this if statement, if in message element 1, if the index 1, which is, remember, our second element of our array, because we start counting at 0. If the second element is 1, meaning our button is pressed, then every loop of the draw function where that is true, we're going to generate a random color, which is what's happening right here when I'm pressing the button, when it goes into rainbow strobe mode. And then our last line of our draw function is drawing this ellipse. And the way that we're using it is we're using our map function, and we're mapping our incoming data in the 0 index of our in-message array, which theoretically has a maximum and minimum range of 10, 23, and 0. We're mapping that to the size of our sketch. So I can play with this, the parameters of this map function to make this react in different ways. Like, so for example, I'm only getting up to like 700 and down to, we'll say 190. So maybe I want to change this to 700 and 190 so that I have a larger range of motion on that circle. So if I do this now, my circle is larger, and if I cover it, it should more drastically shrink. All right. So that is that.